So in this example, players make 839 challenges in the first US Open, and 257 of those challenges were successful. Use a 0.01 significance level to test the claim that the proportion of challenges that are successful is less than 1/3. So the claim in this case is that P is less than 1/3. The proportion of successful challenges is less than 1/3. So I'll use P less than 0.33. 1/3, if you plug that into your calculator, you would get 0.33333. Step 2, we're going to identify the opposite as greater than or equal to. So the opposite of less than is greater than or equal to. Step 3 then is to identify the null hypothesis and the alternative hypothesis and decide which one corresponds to the claim and which corresponds to the opposite. Now in this case, since the opposite has the equal sign, that will correspond to our null hypothesis. And since the claim has less than and no equal sign, then that'll correspond to our alternative hypothesis. So our alternative hypothesis is P is less than 0.33, which tells me it's a left tail test because of the less than. And my null hypothesis is P equals 0.33. So now let's calculate the test statistic. Plugging all this into our formula, P hat will come from the 257 divided by 839 challenges. P will be the 0.33 from the null hypothesis, which makes Q 0.67, and N in this case is 839. So plugging all this in, we get a test statistic of negative 1.46. So now let's identify the critical value corresponding to a 0.01. So this is the first place where the critical value method differs from the p-value method. Up until now, they've been exactly the same in the steps. So we want to look at our significance level 0.01 and identify the critical value corresponding to 0.01. That is the critical value or the z-score that has 0.01 to the left of it. Now since this is a left tail test, we're looking for 0.01 to the left. But if this was a right tail test, we'd want to know the z-score that had 0.01 to the right of it. And if this was a two-tail test, we would take that significance level, split it into two tails equally, so 0.005 and 0.005, and then decide what the critical values are that separate those areas. So in this case, let me look up 0.01 on my normal distribution chart, which is approximately negative 2.33. So we're going to use negative 2.33 as our critical value. Notice that our critical value, negative 2.33, was further to the left than our test statistic, negative 1.46. So if our test statistic falls into the critical region, which would be the area beyond our critical value, then we would reject the null hypothesis. But since our critical value was further to the left than our test statistic does not fall into the critical region. So we say our test statistic, negative 1.46, is not more extreme than our critical value, so it doesn't fall into the critical region, so we fail to reject the null hypothesis. Now, if our test statistic was further to the left than our critical value, we would reject the null hypothesis. So step 7 now is to interpret the results. Since we failed to reject the null hypothesis, we're going to we're failing to reject the null hypothesis. I'm going to cross out the alternative hypothesis, which means I'm going to circle my opposite in this case. So effectively what I've done is crossed out the claim, which is going to tell me that we don't have enough evidence to support the claim that successful challenges are less than 1/3 of the time.